Hello class, my name is Madam Ruth Onaka. I'll be taking you through physical science in this term. We are going to start with topic 1, which is atomic structure and bonding. The objectives of these lessons are: number 1, I expect you to define terms used in atomic structure and bonding. I expect you to describe atomic structure and all the components in it. Number 3, expect you to explain the importance of outermost electrons in chemical bonding by the end of this lesson. Next, I expect you to outline the main features of chemical bond by the end of this lesson. Last but not least, I expect you to explain all the types of bonds. There are several, and you will know them by the end of this lesson, and you'll be able to explain all of them. That's all about our objectives. We are going to start by our first subtopic, which is definition of terms. Under definition of terms, we are going to look at several definitions of terms which will be used in this lesson. Number 1, we are going to look at an atom as our first term. An atom is the smallest part of substance that can be broken chemically. Yeah, that is it. Second, we are going to look at mole. Mole will interfere with this, so you must know its definition first, and it is the unit of amount of substance in international system units. Next term is proton. It is subatomic particles with a positive electrical charge. Electrons is a subatomic particles with a negative electrical charge. Next subtopic, my students, we are going to learn about atomic structure, and we are going to start with its definition. It's a structure which consists of protons, electrons, and neutrons. We are going to look at structure as explained in this diagram. You can see in this diagram, we have 2 layers, the outermost layer and the inner layer. and it is a structure of atom which is called carbon. You know there are many atoms, therefore I expect you to go and look at periodic table where you will learn more of them. And that assignment, I'll look at your periodic table in the next lesson. Therefore, in this diagram, we have two layers, as I have said. The inner layer consists of nuclear as a whole, and under nuclear we have two substances. As you can see, there's green one with a plus, the positive sign, and there is also red balls, and the red balls indicate neutrons. Positive green balls indicate protons. Therefore, the innermost layer contains nucleus, which consists of both protons and neutrons. Then the outermost layers consist of electrons, which is positively charged. Okay, we are going to importance of outermost electrons in chemical bonding. Under that, first you must know what is this outermost electrons. These outermost electrons, they are just electrons in the outermost layer, and their other name is always valence electrons, and their other name is always called valence electrons. Therefore, the importance are several, but we are going to look at this main importance of them. First importance is that they are responsible for chemical bond formation. They are responsible for chemical bond formation. This is whereby the atom shares or gives up electrons from their outermost shell to bond and create new homogeneous substances. Next, we have another importance, which says that they govern an atom selection of electron affinity. Under that, I think you don't know what electron affinity is. It's simple. It's just energy released or absorbed when neutral gas phase atoms receives an electron. Yes, it's all about that. Then we have another importance, which says that they affect an atom's electronegativity. Electronegativity is a chemical property that measures the tendency or power of an atom to attract electron density from another atom to itself. As you may already know, periodic trends also apply to electronegativity. When moving across a row from left, that is from left to right, the electronegativity of elements increases. This is because the nucleus charge of elements increase and atom sizes decrease. Then we have another importance, is that they determine the atom's stability. that determines the atom's stability. In this case, valence electrons are responsible for given atom stability. That means that according to the octet rule, atoms tend to gain or lose electrons to achieve the octet state. At this point, they become stable. For example, examples of stable elements are inert gases, which features 8 electrons in the valence shell. Is that okay? Yes, and that's all about importance of outermost electrons. Next, we are going to features of chemical bond. We are going to start with the definition of chemical bond, which says that it involves atoms combining to form chemical compounds and bring stability to the resulting product. After knowing this meaning, the meaning of chemical bonds, that's when you'll be able to identify their features. And the main features that chemical bonds have are: number one, they hold atoms together inside the chemical molecules. 2, generally the numbers of electrons are always even. Thirdly, covalent bond can exist as a gas, solid, or liquid. Next, ionic bond have high melting point and boiling point. Last but not least, some covalent bonds are soluble in water, while others are in organic solvent. This means that covalent bonds, they normally dissolve in water, and others are organic solvent. Types of bonds. We are going to look at various types of bonds, and there are two main. That is ionic bond and covalent bond. I'm going to start by ionic bond, which is a bond that results from electrostatic attraction or force between ions of opposite charges. Ionic bonds apply to ionic compounds, which is sodium chloride. In simple ionic compound, the metal elements loses outermost electrons to form the cations, and non-metal elements gains electrons to form an ion. We are going to look at structure as explained in this diagram. You can see in this diagram, we have two layers, the outermost layer and the inner layer, and it is a structure of atom which is called carbon. You know there are many atoms, therefore I expect you to go and look at periodic table where you will learn more of them. And that assignment, I'll look at your periodic table. Okay, we have covalent bond, so it can be nonpolar or polar. For covalent bonds formed between two identical atoms, the electron pairs are shared equally between the two nuclei. Electron density is distributed evenly through the bond, making bond a polar bond. We have examples. Example 1, we have a mononuclear molecule. This consists of hydrogen-hydrogen bond, chlorine-chlorine bond, oxygen-oxygen bond. Next example, we have a heteronuclear bond. This bond is formed between two different atoms. The electron pairs are more attracted to the atom that has the strong ability to pull electron pairs towards itself. The ability is measured with electronegativity. The end of the lesson. Goodbye.